Hello everyone, welcome to the first character of Huawei HCIP OpenELR course. This section, we will continue to introduce the common service management of OpenELR. In the previous section, we have successfully installed and started the Apache HTTP service, and you can view the Apache interface in the browser. After you are familiar with the configuration file, let's change the configurations in this section and set the Apache main page and experience the key features we mentioned earlier.
Next, we try to modify the listening IP address and port number. Previously, all IP address and port 80 can be accessed by default. This time, we set the client to allow only port 81 of the HTTPD server IP address to access the server. And here, we do not directly delete the default setting in the configuration file. Instead, we modify the configuration file by creating a new configuration file in the directory of the extended configuration file to facilitate future maintenance. And first, as we mentioned earlier, to add an extended configuration file, you need to comment out the listen line in the main configuration file first. So here we use vim and the main configuration file to open it, and then we check listen configuration. Here, listen port 80. We use the hash to comment out this configuration, and then we save and quit. We continue to create the configuration file named port.conf in the extended configuration directory to set the listening IP address and port number, and finally only allow our local IP to access the HTTPD. Before we do this setting, first we need to run ifconfig command to obtain our private IP address. For here you can see my private IP address is 2.81. We run the vim command and httpd conf.d port.conf command to create the configuration file in the extension configuration file directory. We enter listen and our private IP address port 81 in the configuration file. Then we save the file and exit. After that, we need to run the reload command to reload the HTTPD configuration file for setting to take effect. So here, system control and reload HTTPD and enter. Now we set the configuration, and now let's test. We use a kern and our private IP port number 81 command to test the page. Here you can see the page can be accessed. If we kern the default port 80, let's try whether it still can connect. Okay, because the port is incorrect and the access fails, the error message failed to connect is displayed. If we use our loopback IP address and also use port 81 to test, because we have configured the listening IP address only for our private IP address, 2.81. As a result, the error connection refused is also reported. So far, we have strictly restricted the IP address and port number that can be accessed to the HTTPD service. So here we have a new question, that is, if we don't comment out the main configuration file in advance, can we do this also? Actually, the answer is no. If you do not comment out it, the client can still access the service through port 80. In addition, it is also possible to modify the main configuration file directly. However, if the main configuration file needs to be modified later, for example, the previous default configuration needs to be restored, the main configuration file needs to be modified rapidly, which is not very good for the continuous maintenance. And now let's configure the main page so that the HTTPD server will return a greeting hello open error. So first we run the command cd to the 3w-html, the home directory of HTTP, and then we use ls command to check the file is empty, so we run touch index.html command to create the index.html file. And then we run echo and hello open euler send to index.html. Add this content to the HTML file. Okay, and after setting the default page under the home directory, we reload the service. It's also we use the command system control reload HTTPD. After loading is complete, we run curl the private IP with port 81 command. Note that this local private IP address and port 81 is still used. Access the server again. It's changed to hello open euler. And then we can modify the directory for storing the main page. The original main directory, that is the var3w-html. Let's create a new directory, home source. Move the index.html into the new directory and have the server return hello open euler as well. So first, we modify the main configuration file as well using the vim etc httpd.conf.httpd.conf. And then it's also do not modify the content directly. You can also extend the configuration file by adding a comment before the var3w.html in the document root line. And then we save the file and exit. Okay, now we run the make directory and home source command to create a new directory, and then run the move command, move the index.html to home source directory. We create a configuration file in the extended configuration file directory, so we run the command vim etc httpd and conf.d source.conf command. We also enter the new configuration document root. We change it to home source. Okay, and after that, we save the file and exit. Next step is also the same. To reload the service, system control reload HTTPD. Okay, after that, we access curl the private IP and port 81 again. But now the command output is not the hello open euler. It is the default HTML page. So let's think about why. It is because based on the error log file, we can check. So let's open the error log. And from the error log, we can find here the client domain by server configuration, home source. Okay, so it means our home source configuration have something wrong. So therefore, we need to add the access permission for the new directory home source so that we can use. Okay, so now let's again use Vim, open this home source file. We add the same permission description as that's in the main configuration file under this original configuration line. So here we added the configuration. The allow override is none and required or granted. And here the absolute path can be entered in the directory. The absolute path is home and source. If the relative path is entered, it is relative to home directory. And then let's save and quit, and also we reload HTTPD and then access the server IP address. Again, the web page content hello open Euler. In the main configuration file, the default access page is index.html, which is also used. And now let's try to change the name of the access page. First, we need to run the cd command to home source and switch the directory for storing the new main page. And then we run the command, because here we have the default index.html, and this is the commonly indexed. We run the command move to change this to capital I index.html, and then we also check the result. We use kern, our IP address again, the arrow kerns again. There is no correct page. This is because the index in the configuration file need to be matched in the lowercase. So in this example, only capital indexed is used. Therefore, the file cannot be matched. So in this page, we need to modify the configuration file that has just changed the home directory. And also, we add the default page name to the configuration, but if only one line to edit, we can directly run the echo command. So after all, it is a little troublesome to open and edit the file using Vim. Echo, we change it to capital I index.html, send to source.conf. We reload the system control HTTPD service and access the service by using kern IP address. And then we check the result. Now the message hello open Euler are displayed. So far, we have set the listening IP address and port number of the HTTPD service, modified the contents displayed on the main page, modified the directory for storing the main page, and modified the name of the main page. So that's the last question. Can one HTTP server return different static page for different users? Actually, the answer is yes. This is a virtual host function of the Apache HTTP service, which we will describe later. We mentioned earlier that the Apache HTTP server has some key features, such as modularization, DSO dynamic function module load and unload, and MPM multiple processing module. Now let's get familiar with these features through configuration. The dynamic function module is stored in the user library 64 modules directory. So we can use ls command httpd modules to view. And here view the .so files of these modules. You can also use httpd-m to display all modules supported by the server and their status. The first three, core, SOAP, and HTTP states are static, which are the core static modules. The first core module, this is a core module of the Apache server, which provides the basic function of the server, including processing HTTP requests and building HTTP responses. When a server receives an HTTP request, the core module parses the request, determines how to process the request, generates an HTTP response, and sends it to the client. SOAP module is used to process shared object files, the .so files of the server. In Linux, the SO files is a core sharing mechanism that allows multiple programs to share the same library code, saving memory and improving efficiency. So the SOAP module is responsible for loading and parsing these shared object files. HTTP modules provide support for the HTTP protocol, defines the format of HTTP requests and responses, and provides methods for processing these requests and responses. For example, when a server needs to return an HTTP response, the HTTP module generates the header and body of the response and ensures that they conform to the HTTP protocol. These three static modules are required for the Apache server to run. They are loaded at server startup and run throughout the service lifecycle. Because they are statically compiled into the server, they cannot be load or unload dynamically at server runtime. The rest of these shared status are dynamic modules that allow the server to add or remove features with rebooting, providing more flexibility. This is what we call the loading and unloading of DSO dynamic function module. And among these, the mode status module is used to provide a status page on the Apache server. This page displays the performance and running status of the Apache server, including the current active request, connection status, and module statistics. This module is a useful tool for monitoring server performance, troubleshooting problems, and tuning performance. To enable this module, you need to add specific instructions to the Apache configuration file and view the server status information by accessing specific URLs. So we run the http-m and the pipe grep status command to check whether mod status has been loaded. If status modules is shared is displayed, the module has been loaded. And then we configure the relevant permissions and enable extend status so that the module can be used. We use the command vim conf.d and module.conf to add a configuration file in the extended configuration file directory. We write the content of status and enable extend status. Okay, I copy the content and here we have opened the extend status. We save and exit and reload the HTTPD. Okay, after that, we can enter the public IP address of the HTTP server in the address box of the browser and use port 81, the port number we have changed before. We added with the location status path to view the Apache server status. So here we use our public IP and server status. Okay, we can see that the public and private IP address and the current version of Apache is 2.4.51 and the current npm mode is event mode and the current PID and connection request status. Next, we try to uninstall the status modules. So let's go back to the command line interface. Okay, here we need to edit the $0 configuration file to modifying. So we use vim command etc httpd conf.modules.d. This is the directory. Here we enter the configuration file name $0base.conf. Okay, now we open the file. We can see all of the modules command here. And here we can see the status modules. It have load mode status.so files. Okay, so now we want to dynamic uninstalling this module, so we can use hash to command out it. And we save and exit. Reload the service configuration, and then we access the public IP address, also with 81 port. We can see not found is displayed. The information cannot be viewed. In this case, the module is uninstalled during service running. But because this module will be used in subsequent practice, so therefore we modify the configuration file again. We delete the comment character and reload the Apache configuration to restore the module. Return to the browser page, and then we refresh the page. The status is displayed. Load the function module in the running of the server. Okay, this is the DSO functionality demonstration. Let's look at the npm multiprocessing module feature. In fact, you can also view the npm module features on this interface. Here, the npm module mode is event. And also, we can, on the command line, you can also view the working mode of the npm. We run the httpd-m and grep npm command. The command output shows loaded modules is npm event module shared. That is the event mode. Or alternatively, you can also run the http-v command to view the server npm event in the display details of the npm service. So therefore, we can run the page or M or V commands to view the information. And also, we can view the module configuration file. We use the command vim. We can use the vim and also this the same path config.module.d. Here we have npm.conf file. We can see the current value from this configuration page. Load module npm event module. And also here it have a worker module, prefab module. Which mode you want to use, you can use the module, and if you don't need, you can comment out the other modules. And now we will comment out the event module. We open the worker module, save and quit, and also we reload HTTPD. But notice that the npm determines the working mode of the HTTP process and strings. Reloading will interrupt the service. So therefore, we need to start the service so that the new npm mode take effect. And after the service is restarted, you can run the HTTP V command to see that the working mode has changed to worker. Alternatively, you can also run the command -M to view the module loading information or refresh the page. The working module of the npm also has been changed. Okay, so this is a demonstration of the npm. In addition, our HTTP service also supports short connections and persistent connections. So let's look at the configuration of the persistent connection. First, on a page of the status model of the browser, you can see that the value of keep alive in the current connection is 0. That is, persistent connection is not enabled. So now we can back to the command line page to configure this parameter. First, in the extended configuration file directory, we added a configuration file for persistent connections. We can use this vim command and conf.d and keepalive.conf. We added the configuration to the file. It's also I copied it, and here the timeout is 20 and request is 500. And then we reload the HTTP service. And after we reload the HTTPD service, we can back to the browser interface. And here we can refresh first. But here we cannot see the table. So the other code may be required. You can press F12 to view the Keep Alive configuration status in the network configuration page. From here, we can see the required method is get. The connection is keep alive. So it means we have opened the persistent connection. So this is the Apache persistent connection configuration.
In this section, we have changed the listening IP address and port of the HTTP service, modified the contents displayed on the main page, modified the directory for storing the main page, modified the main page name, and also we practice loading and uninstalling the dynamic functional modules of the key features of the DSO. And also, we adjust the working mode of the npm multiprocessing modules. And finally, we try to configure the persistent connections. Next, we will configure static resources for the Apache HTTP service, and then practice the configuration of the virtual host mentioned earlier, and implement the HTTPS. Thank you for watching.